Welcome to my algebra class. We are on chapter 8, sections 9, direct variation, and 10, indirect variation. So here we have direct, and here we have indirect, and I have a couple videos for you to, at least one video for you to watch. And then we'll do the evens.
Welcome to a quick lesson on direct and inverse variation. For direct variation, the following statements are equivalent. Y varies directly as x, y is directly proportional to x, and y equals kx for some constant k. So if we see any of these key words or this key equation, we know we're dealing with direct variation. The number k is called the constant of proportionality. And one more thing we should notice, if we have the equation y equals kx, this would be a line passing through the origin, or have a y-intercept of 0, and the slope of that line would be k, the constant of proportionality. In general, if two quantities vary directly, if one quantity goes up, so does the other, and if one quantity goes down, the other also goes down. Let's take a look at an example. So again, going back to the given information, since we know that y equals 28 when x equals 7, constant of proportionality. Next, we're told that y equals 28 when x equals 7. The reason that's so important is that is going to allow us to determine the constant of proportionality. Let's go ahead and finish the question. It says determine the direct variation equation and then determine y when x equals 3.5. So again, going back to the given information, since we know that y equals 28 when x equals 7, we can now find k. 28 must equal k times x, which is 7. So solving for k, we'll divide both sides by 7. We know that k is equal to 4. So that tells us our direct variation equation is y equals 4x. Now we can determine y when x is 3.5, because y is going to equal 4 times 3.5. So y will equal 14 when x equals 3.5. Thus the centimeter. Indirectly as x. Okay, let's talk about indirect or inverse variation now. The following are equivalent for inverse variation. We can state that y varies indirectly as x, or y is inversely proportional to x, or y equals k divided by x for some constant k. And in general, if two quantities vary indirectly, if one goes up, the other goes down, and vice versa. Let's take a look at a couple examples of this. Again, the first sentence is very important. It says y varies inversely as x. That's telling us our equation will be y equals k divided by x. The next sentence states y equals 27 when x equals 1/3. We want to determine the inverse variation equation and then determine y when x equals 18. This second sentence will allow us to find k. It says when y equals 27, x is equal to 1/3. So using these values in this equation, we have 27 equals k divided by 1/3. Now there's a couple ways to solve this, but if we put this 27 over 1, we have a proportion where k times 1, that will give us k, must equal 27 times 1/3. Well, multiplying by 1/3 is the same as dividing by 3, so this would be k equals 9. So now we have our inverse variation equation, y equals 9 divided by x. So now we can determine y when x equals 18. Y equals 9 divided by x, but x is 18. So that tells us y is equal to 1/2 when x equals 18.
Okay, that concludes the explanation of direct and indirect variation. So we're ready to do the assignment, which is on page 393 to begin with. Then we move to 395 and then 400. So we're starting on 393. Head your paper, skip a line, put the title down, and we're on number 2. They want us to find the constant of variation. So number 2, y equals directly as x, so it'd be kx. When y is 6 and x is 72. So we divide both sides by 72, so our constant of variation is going to be 1/12 equals k. Problem number 4. H varies directly. H equals k as m, km. H is 112 when m is -16. So we're going to divide both sides by -16. And positive divided by negative is negative, and it goes in evenly 7. So our constant of proportionality is -7. Problem number 6, P is directly proportional K to T. P is directly proportional to T. When P is 210, T is 14. So dividing both sides by 14, use your calculator. 14 goes into 210 15 times, so K is 15 for that one. Number 8, D varies directly as Z, so D equals KZ. D is 6, and Z is 48. So dividing both sides by 48, we get 1/8 equals K. And then they want us to find D when Z is 20. So we know K is 1/8, so we put that in for K. And then they tell us Z is 20. So D equals 20/8, which is 2.5 or 2.5. And 10, the last problem on this page, R is directly proportional to A. R is 14 and A is 87.5. So divide both sides by 87.5. And if we use our calculator, 14 divided by 87.5 equals 0.16. And then they want us to find R when A is 25. So we put in 0.16 for K, and for A we put in 25, which is, and then times that together. So 0.16 times 25 is 4. Now we're on page 395, problems 1 to 10. Problem number 2. A certain car uses 15 gallons of gasoline in 3 hours. If the rate of gasoline consumption is constant, how much gasoline will the car use on a 35-hour trip? We're going to use direct variation. So the amount of gasoline varies directly as the time used. So we'll say gasoline equals K times time. So we used 15 gallons and the time was 3. So if we divide both sides by 3, 5 equals your constant of proportionality. So the rate, how much gasoline, G, will be used by a car on a 35-hour trip. We know K is 5, so we put 35 for the time. And 5 times 35 is 175. So we use 175 gallons. Problem number 4, the distance traveled by a truck at a constant speed varies directly with the length of time it travels. So speed varies directly as the time. So if it travels 168 miles in 4 hours, how far will it travel in 7? The distance, I'm sorry, is not the speed. So the distance is 168 and the time is 4. Divide both sides by 4. 4 goes to 168 42 times. So our constant of proportionality is 42. So they want to know how far will it travel in 7 hours. So D equals 42 times 7. And that would give us 294 miles. Problem number 6, when an electric current is 32 amperes, the electromotive force is 288 volts. So the current varies directly as the force. So we have a current of 32. It varies directly as the force, and the force was 288. So if you divide both sides by 288, (32) divided by 288 is 1/9. So 1/9 equals our constant proportionality. And they want us to find the force when the current is 65. So 65 equals 1/9 of a fourth. Multiply both sides by 9. And we get 585 volts equals the force. Problem number 8, a restaurant buys 20 pounds of beef to prepare 110 servings of chili. At this rate, how many servings can be made with 30 pounds of ground beef? So the amount of beef you buy varies directly as the amount of servings you'll get. So 20 pounds equals K times 110. Divide both sides by 110. And we get 2/11 equals the constant of proportionality. So at this rate, how many servings can be made with 30 pounds? So we have 30 pounds, and our constant of variation is 2/11, and servings we're looking for. So multiply both sides by 11 halves. Get rid of the 2/11. And 2 goes into 30 15 times, and 11 times 15 is 165. So we'll get 165 servings. And the last problem, the amount of chlorine needed for a pool varies directly. So the chlorine varies directly as the size of the pool. So if 5 units of chlorine is the amount needed for 2,500 liters, let's find the constant of variation, divide by 2,500. And we get 1/500 equals K. So now we want to know how much chlorine is needed for 3,750 liters. So K is 1/500. And we times that by 3750. We can drop that. And 375 divided by 50 equals 7.5. So we'll need 7.5 units of chlorine. And the last part of our assignment is on page 400. And this is inverse variation. So problem number 2. 3 friends on a fishing trip pay $100 each to share the rent of a cottage. The cost per person varies inversely as the number of people. So as the cost goes up, the number of people go down. Number of people go up, the cost goes down. So we have 3 friends, and they're going to pay $100 each. So 100 equals K over 3. Multiply both sides. Well, you can do cross products, so 300 equals K. How many people would have to share the rent of the cottage to make the cost $60 per person? So 60 equals 300 divided by K. So 60K equals 300. Divide by 60. And we would need that should be people down here. Let's change this to people. And the number of people needed would be 5. Problem number 4. The winner of a race ran the distance in 45 seconds at an average speed of 9.6 meters per second. The runner who came in last finished in 48 seconds. What was the last runner's average speed? The distance ran varies indirectly or inversely as the time. So K over time. So the distance was 45 seconds equals K over 9.6. So take 45 and times it by 9.6. And our constant of variation is 432. What was the last runner's average speed? This should be, I think I made a mistake. This should be speed here. Okay. So we're looking for the last runner's average speed. Okay, and again, well, that's right. I just have the units where this should be speed. This was the average speed, and this was the time. So this person, his time was 45, and his average speed was 9.6. This person, okay, we have a constant variation of 432. So what was the last runner's average speed? So we have 48 seconds is the time it took him. Constant of variation is 432, and we're trying to find his average speed. So 48s equals 432. Divide by 48. And our speed would be 9 meters per second. Problem number 6. A gear with 42 teeth revolves at 1,200 revolutions per minute and meshes with a gear having 72 teeth. What is the speed of the second gear at the rotational speed of the gear? So the speed of the gear varies inversely as the number of teeth. So a gear with 42 teeth revolves at 1,200 revolutions per minute. So this is the speed of this one was 1,200, and it has 42 teeth. So we take 1,200 times 42, and we get 50,400. So now we want to know the speed of the second gear. So the second gear, we're looking for its speed. K is 50,400, and its number of teeth is 72. So we just need to take that 50,400 and divide it by 72, and it's 700 revolutions per minute. Number 8, the number of plants used to fill a row of given length in a garden varies inversely as the distance between the plants. So the number of plants varies inversely to the distance between the rows. We have 75 plants are used to fill the row when planted 20 centimeters apart. So the distance apart is 20. So cross multiply, we get 20 times 75, which is 1,500 equals K. And the question is, how many plants are used to fill the row when they're planted 15 centimeters apart? So we're looking for the number of plants. K is 1,500, and this time they're planted 15 centimeters apart. So if I divide 1,500 by 15, we can get 100 plants. And problem number 10, a string on a violin is 25.8 centimeters long and produces a tone whose frequency is 440 hertz. What is the length of a string needed to produce a tone of frequency 516 hertz? If the frequency of a vibrating string is inversely proportional to its length. Well, let's find K first. The frequency that they first gave us was 440 hertz for a length of 25.8. So take 440 and times it by 25.8, and we get 11,352. So now we need to find the length of the string needed to produce a tone of 516 hertz. So 516 equals 11,352 over L. So 516L equals 11,352, divide by 516, and we get 22. So the length is 22 centimeters. That concludes the evens. Be sure and check the back of the book for the answers to the